Hello everyone. At present we are learning about the zeros or roots of a polynomial. In part 1, the previous video, we have learnt about what are the zeros of a polynomial, how to find out the zeros and what is the geometrical meaning of the zeros of a polynomial. In this second part, we will be learning about the relationship between the zeros and the coefficients of a quadratic polynomial as well as a cubic polynomial. And also we will learn how to construct a polynomial if its zeros are given. Let's talk about the quadratic polynomial. We know a quadratic polynomial px equal to ax square plus bx plus c. It is a general form of a quadratic polynomial. Here a, b and c are known as the coefficients of the polynomial. Suppose the zeros or the roots of this are alpha and beta. Let the zeros of px be alpha and beta. Then we know if there are two zeros, then there will be two factors of it. Therefore, x minus alpha and x minus beta are the factors of px. Now we know that there is a coefficient a multiplied with x square. So what we can consider? We can consider that ax square plus bx plus c is equal to a into x minus alpha into x minus beta. Now if we simplify this, we are getting here this is x square minus alpha plus beta into x plus alpha into beta. Multiplying this a with each term, we are getting ax square minus a into alpha plus beta into x plus a into alpha into beta. Now we know that two polynomials are equal if the coefficients of their corresponding terms are equal. Here also these are two polynomials. So they are equal means the coefficients of x square, that of x, and the constant terms are to be equal. If we compare these, we can write comparing the terms, we get the coefficient of x square is same a, the coefficient of x, that is b is equal to minus a into alpha plus beta. This gives us alpha plus beta is equal to minus b upon a. And if we compare the constant terms, c is equal to a into alpha into beta. It means we get alpha into beta is equal to c by a. These two are known as the relationship between the zeros and the coefficients of a quadratic polynomial. So we have the relationship alpha plus beta is equal to minus b upon a and alpha into beta is equal to c upon a. Based on the relationship, we are asked sometimes the questions like, for px equal to 3x square minus 8x plus 5, verify the relationship between the zeros and the coefficients. So what we do in such problem, we will take the polynomial px equal to 3x square minus 8x plus 5. First of all, we have to find out its zeros. For that, we have to factorize it. And that we can do by splitting the middle term. 3 5 are 15 and 3 and 5 8. So we can write this as 3x square minus 3x minus 5x plus 5. And we are getting here 3x common, x minus 1. Minus 5 common, x minus 1. So the factors of this we are getting are x minus 1 into 3x minus 5. We know for zeros we have to equate this to 0. So we write for zeros px equal to 0. It means x minus 1 into 3x minus 5 equal to 0, which implies that x is equal to 1 over 5 by 3. So these are the zeros. We can write therefore the zeros are alpha equal to 1 and beta equal to 5 by 3. Now if we find the sum of these zeros, alpha plus beta, that is 1 plus 5 by 3, taking LCM we are getting 3 plus 5, 8 upon 3. What about minus b upon a? Here in this polynomial we are having for px, a is equal to 3, b is equal to minus 8 and c is the constant term, that is 5. It means minus b upon a will be minus 8 upon 3, which is equal to 8 upon 3. Are we getting both equal? So we can say this implies that alpha plus beta is equal to minus b upon a. The first relation is verified. Let's go for the second one. Alpha into beta, we get 1 into 5 by 3, that is equal to 5 by 3. And if we get the value of c upon a, from here c is 5, a is 3. Are they equal? So we can say from this that alpha into beta is equal to c by a. So second relation is also verified. So we can write hence the relationship is verified. This is the way we can verify the relationship between the zeros and the coefficients of a quadratic polynomial. Sometimes we are given the zeros of a polynomial and we are asked to construct it. That is construction of a quadratic polynomial. Suppose the zeros which are given to us are alpha and beta. So we can write let alpha and beta be the zeros of px, that is polynomial. Now we know if alpha and beta are the zeros, this implies that x minus alpha and x minus beta are the factors of px. And if these are the factors, we can write this as px is equal to x minus alpha into x minus beta. If we simplify this, we are getting x square minus alpha plus beta into x plus alpha into beta. This can be applied as a formula to construct the polynomial whose zeros are alpha and beta. We can also write this as x square minus sx plus p, where we say that alpha plus beta is the sum of the zeros, we write it by capital S, and alpha into beta is the product of the zeros, so we can write this as p. X square minus sx plus p is the polynomial. We will discuss now one problem based on the construction of a quadratic polynomial whose zeros are given to us. The problem is find the polynomial whose zeros are 1 upon 3 and 1 upon 4. We can find the solution of such problem in 3 different methods. And the first method here is we will write these zeros as alpha and beta as we know. So we can write alpha is 1 by 3 and beta is 1 by 4. We know that if alpha and beta are the zeros of a polynomial, x minus alpha and x minus beta are its factors. So we will find the product of x minus alpha and x minus beta in this case. That is x minus 1 upon 3 into x minus 1 upon 4. But we will not write that this is the polynomial. Why? Because the zeros are in fraction. And we find the product, that will be x square minus 1 upon 3 plus 1 upon 4 into x plus 1 upon 3 into 1 upon 4. This is x square minus 7 by 12x plus 1 by 12. We'll take the LCM in such case, that is 12. And we find here 12x square minus 7x plus 1. So we can write that the numerator of this part is the polynomial. Therefore, we can write the polynomial is px equal to 12x square minus 7x plus 1, and this is the answer. The second method here we can apply is that we are given the zeros 1 by 3 and 1 by 4. So we write alpha equal to 1 by 3, beta equal to 1 by 4. And we find the sum of the zeros. Sum of the zeros, we write this as S. That is equal to alpha plus beta is equal to 1 by 3 plus 1 by 4, which is same as 7 by 12. Then we will find the product of the zeros. Product of the zeros, that is P, is equal to alpha into beta is 1 by 3 into 1 by 4, which is 1 by 12. And then we can find the value of x square minus sx plus p, which is equal to x square minus 7 by 12x plus p means 1 by 12. Taking the LCM 12, we get here 12x square minus 7x plus 1. And the same way as I told you there, leaving the denominator, only the numerator is the polynomial. So we write therefore polynomial px is equal to 12x square minus 7x plus 1. This is the answer. The third method for the solution we can take here is we consider the polynomial. Let the polynomial px be ax square plus bx plus c, because we know there are two zeros, so it is to be a quadratic polynomial. And we have been given alpha is 1 by 3, beta is equal to 1 by 4. We find the sum of them, that is alpha plus beta is equal to 1 by 3 plus 1 by 4, that is 7 by 12. And we also know that alpha plus beta is equal to minus b upon a. So we can write this is minus b upon a. Similarly, we write the product alpha into beta, that is 1 by 3 into 1 by 4, which comes as 1 by 12. And we also know that alpha into beta is c by a. So we can write this is equal to c by a. The important part here is that we have to see that the denominator of both these numbers should be same. If it is not same, taking the LCM and multiplying some certain required number, we will make them equal. Why it is so? Because both have the denominator as a. If they are equal, we can take this value as a by comparison. So by comparing these two values, we can get the value of a as 12. From this we are getting 7 is equal to minus b, it means b is minus 7. And from this we are getting c is equal to 1. After finding these values of a, b and c, we can substitute that here in this px. So we can write therefore px is equal to ax square plus bx plus c, which is equal to a means 12x square, b means minus 7 into x plus c means 1 plus 1 equal to 0. So you have seen that any of the three methods we apply, the answer is to be same. When we talk about the cubic polynomial, we know that the standard form of a cubic polynomial is ax cube plus bx square plus cx plus d, where a, b, c and d are the coefficients and the constant terms of the polynomial. And we know that at most there will be 3 zeros of a cubic polynomial. Suppose the 3 zeros of this are alpha, beta and gamma. Let the zeros be alpha, beta and gamma. Then similarly, as we found the relationship for the quadratic polynomial, we can find the relationship for the zeros of a cubic polynomial also with its coefficients. And that is alpha plus beta plus gamma, the sum of the zeros is given as minus b upon a. The sum of the product in pairs is alpha into beta plus beta into gamma plus gamma into alpha is given by c upon a. And the product of all the three zeros, that is alpha into beta into gamma, is given by minus d upon a. These relations can be applied to find the polynomial if it's all the three zeros are given to us. We can take one example. Suppose we have to find a polynomial whose zeros are given as alpha equal to 2, beta equal to 4 and gamma is equal to minus 1. So we can write, let the polynomial be ax cube plus bx square plus cx plus d. Then we find the sum of them, alpha plus beta plus gamma is 2 plus 4 minus 1, that is 6 minus 1, 5. We find the product of the pairs and the sum of them, that is alpha into beta plus beta into gamma plus gamma into alpha, which is 2 into 4 plus 4 into minus 1 plus minus 1 into 2, and that is equal to 8 minus 4 minus 2, that is 2. We know that this alpha plus beta plus gamma is equal to minus b upon a. We know that this product in pairs and the sum of them is equal to c by a. And if we find the product of all the three, alpha into beta into gamma, that will be 2 into 4 into minus 1, that is minus 8. This is equal to minus d upon a. We are finding here that a is 1 because the denominator of each is 1. They are all integers. And then we can see b, comparing this part, we are getting b is minus 5. C from this we are getting is 2 and d from this we are getting is 8. After finding these values, we can write therefore the polynomial px is ax cube plus bx square plus cx plus d. Substituting these values, a is 1 into x cube plus b, that is minus 5 into x square, plus c, that is 2 into x, and plus d, that is 8. So we get the answer as x cube minus 5x square plus 2x plus 8, which is the cubic polynomial whose zeros are 2, 4 and minus 1. So we will learn here what are the relationship between the zeros and the coefficients of the polynomials and also how to apply them in different type of problems. In the next video, we will learn about the symmetric forms of the zeros of a polynomial. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.